This lesson is the first in a series of 3 lessons on ratios and proportional relationships. We have chosen to design this series of lessons using the 5E lesson plan format: engage, explore, explain, elaborate, and evaluate. Three, three lessons are intended to be delivered in a 90-minute class block, but depending on the individual school's designated time for each class block, the lesson can be divided and delivered in two 45-minute class periods. But for the purposes of our mini teach today, we will use a 90-minute class period.
Here we go, yo. Here we go, yo. So what's the ratio? Here we go, yo. Here we go, yo. So what's the ratio? Hey, yo, Bo knows this and Bo knows that. But Bo don't know how to teach you math. You gotta listen to the stylings of Mr. Austin. My mathematical lyrical prowess is awesome. Sit back, relax, with no distortion, and learn all about ratios and proportions. So let's get in the know about ratios, a comparison of 2 different quantities, yo. If you got 6 dogs and only 3 cats, that's a ratio of 6 to 3 dogs to cats. You can simplify it just like a fraction. Divide top and bottom, yo, that's the action. So the simplified ratio is 2 to 1. That means twice as many Scooby-Doos as Garfield, son. Nothing more, nothing less, it's really that simple. I pop this knowledge while you pop your pimple. Here we go, yo. Here we go, yo. So what's the ratio? Here we go, yo. Here we go, yo. So what's the ratio? I got mad skills in mathematics and more, son. Let me drop some knowledge all about proportions. It's a couple ratios, equal sign in the middle, with the missing variable that we solve like a riddle. The first step you do is cross multiply. Write your answer down below, bring down the equal sign. Now you've got an equation, you need to solve it, kid. But you got it, dude, just like the Olsen twins. When you find your solution, go back up and plug it in and check it by cross multiplying again. If you get the same answer, then you know that you're done. So you can watch Netflix and eat a honey bun.
What did you guys think about the ratio jam? Can anybody guess what we will be learning about today? That's right. Today we're going to be learning about ratios and proportions. I would like you now to make a group of with 2 to 4 fellow mathematicians that you would like to work with today. Now that everyone has a team, I would like each team to draw a 1 by 10 array on the grid paper I passed out. Your array should look like this or like this. Great. Now that you've done that, I would like you to draw 4 more arrays just like the first one. You don't have to number each square in your array like I did. I just did that to make sure I have 10 units in each of my 5 arrays. Now we're going to create a table, a reporting table with 2 rows and 6 columns. Your table should look like this. Great job, math team. Next, your team will pick any number between 1 and 9 and color that number of squares in your first rectangle. After you color in the squares in the first rectangle, record the number of squares on your recording sheet. So color in these squares and record it here. So if my number was 7, my rectangle would look like either this or like this. My table would look like this. One rectangle, 7 squares. Next, I want you to do the same thing in the next rectangle. Color the exact same number of squares as you did in the first array. Only this time on your recording sheet, I want you to mark the total number of colored squares in both arrays. Now repeat this step for the 3 remaining rectangles. Remember, all 5 rectangles must have the exact same number of colored squares. After groups have completed their arrays and tables, students will present the results showing how many squares they shaded in their rectangles and the total number of squares in 2, 3, 4, and 5 rectangles. Students will be asked to talk about how the numbers in the second row are related. If they shaded X number of squares in the first rectangle, the number goes up by X in each column. Students may also say there are 1 times, 2 times, 3 times, 4 times, 5 times the number of colored squares. Mathematician, your table shows something called ratios. A ratio describes a relationship between two or more numbers or amounts. For example, the ratio between the number of rectangles you drew and the total squares that are shaded is a ratio. The original rectangle you shaded also shows a ratio. In this case, the ratio exists between the number of shaded squares and the number of rectangles in all. For example, 7 shaded squares to 10 total squares is a ratio. 7 shaded squares to 10 total squares. This is your ratio right here. A ratio is a comparison of two values. Ratios are used to show relationships between two numbers or to compare two numbers of the same type. A ratio expresses how much of one thing there is in comparison to another. Mathematicians, one really cool thing about ratios and proportions are there are 3 ways to write a ratio, and all 3 of them mean the same thing. For example, there are 5 puppies in total. 3 of these puppies are girls, these 3 right here. 2 are boys. The first way that we can write a ratio is to use words. We use specifically the word two. We would say there are 3 girl puppies to 2 boy puppies. Or we would say there are 2 boy puppies to 3 girl puppies. Mathematicians, it's extremely important the order in which you write your ratio. If you're asked for the ratio of girl puppies to boy puppies, you will put the number for the girl puppies first, because that's the first part it's asking you to compare to, girls to boys. Then you would put the number for the boys after the word two. But if you were asked for the ratio of boy puppies to girl puppies, you put the two first, because they're asking you to compare the boys first to the girl puppies. So you would write 2 to 3. The next way that you can write a ratio is to use a colon. You put a colon in the middle to separate the values. So for girls to boys, you would write 3 colon 2. If you're asked for boys to girls, you would write 2 colon 3. The next way that we can write a ratio is by writing it as a fraction. The top part, you would put 3 because that is the part they're asking you for first. That is the numerator. 3, 2, 2. Depending on the type of comparison or relationship you want to show, there are two types of ratios you can use, part to part or part to whole. Let's take a look at the first type of ratio you can use, the part to part. In this type of ratio, it is showing the relationship between a selected number of values with another number of selected values. This ratio is showing the relationship between the four blue slices of the pie to the six purple slices of the pie. Another example. Let's imagine you made a fruit salad. In your fruit salad, you have a total of 10 pieces of fruit, 2 green apples, 4 pineapples, and 4 strawberries. Remember that a part to part ratio compares 2 parts of the whole. So if we were going to compare the number of apples with the number of strawberries, our ratio would be 2 to 4. What we are saying with this ratio is that there are 2 apples to 4 strawberries in our fruit salad. Part to whole relationship. A part to whole relationship compares a selected number of parts of a whole to the total number of all parts in the whole. This ratio is comparing the 4 blue slices of the pie charts with the 10 slices of that make up the whole pie chart. Another way to think about this ratio is comparing the blue slices of the pie chart with all the slices of the pie chart. Another example. Let's look at our fruit salad again in a part to whole ratio. If we wanted to compare how many pineapples there are in our fruit salad to the total number of pieces of fruit or all the fruit in the salad, our ratio would be 4 to 10. This ratio is saying there are 4 pineapples to 10 pieces of fruit in our salad.
Today on What's Your Problem? We'll learn that a ratio describes the relationship between two quantities. We'll also learn how to make equivalent ratios and show them on a graph. And we'll see that this knowledge can help us learn about pets, volunteer at an animal shelter, and find great deals when shopping. Hey there, I'm Adesina, and welcome to What's Your Problem? The show where we solve all of your problems.
I love my pet rooster, but if he wakes me up one more time at the crack of dawn, I'm having chicken for breakfast.
Not those kinds of problems. Math problems. Today's topic is ratios. For example, try some of my famous banana bread.
What's your secret?
Well, I always use a ratio of 3 bananas to 2 eggs.
What exactly is a ratio?
A ratio describes the relationship between two quantities. Today, we'll explore how ratios can help us learn about our pets and even shop online. Let's explore. Hey, nice pins there.
Thank you.
Whoa.
It's a struggle.
First, let's see how manatees can help us learn about ratios.
So cool.
Remember that a ratio describes the relationship between different quantities. For example, these manatees have 3 flippers for every 2 eyes. We can show that as a ratio of 3 to 2. There are a few ways we can write ratios. We can write them with the word 2 in between, or we can use the colon symbol like this. Or we can write one number over the other like a fraction. We read this as 3 to 2.
So all these different forms mean the same thing. This manatee has 3 flippers for every 2 eyes.
Right. Now, what if we had 2 manatees in total? What would be the ratio of flippers to eyes now?
There are 6 flippers and 4 eyes, so that is a ratio of 6 to 4.
Yes. And if we had 3 manatees?
Now there are 9 flippers and 6 eyes, so that is a ratio of 9 to 6.
Let's take a look at the ratios we created.
You started with 3 to 2, then multiplied both numbers by 2 to get the ratio of 6 to 4.
And you multiplied both numbers by 3 to get the ratio 9 to 6.
Correct. No matter how many manatees there will always be 3 flippers for every 2 eyes. This is an example of a part-to-part ratio because it's comparing the amount of 2 parts. There's one other kind of ratio called a part-to-whole ratio. For example, let's say that I bought a pack of markers, and 1 out of 5 markers in a pack is always blue. I can show that as a ratio of 1 to 5. The 1 is the part, and the 5 is the whole. Try to make a table of ratios that shows what happens if we buy more of these packs.
Well, we know 1 pack can be shown as ratio of 1 to 5.
And if we buy 2 packs, we can multiply both of these numbers by 2. 2 times 1 is 2, and 2 times 5 is 10. So the ratio is now 2 to 10. Then we can multiply our ratio by 3 to represent 3 packs of markers. 3 times 1 is 3, and 3 times 5 is 15. So the ratio is now 3 to 15.
Excellent job, team! You can see that all these ratios are equivalent because they're all multiples of the original ratio.
One thing I don't get is a ratio the same thing as a fraction?
That is a great question. Fractions and ratios are related, but different. For example, let's say you have 20 fish in a tank and 14 of them are blue. You can show that as a fraction, 14/20ths. And you can also show that as a ratio of 14 blue fish to 20 total fish. This fraction and this ratio both show parts of a whole. But now let's say you want to compare the amount of blue fish to yellow fish. We cannot do that with a fraction because fractions only show parts of a whole. But a ratio can show a relationship of parts to parts. In this case, you can show that the ratio of blue fish to yellow fish is 14 to 6. This is a part-to-part ratio.
I get it. So fractions only show parts of a whole, but ratios can compare any 2 quantities.
Bingo! Now let's see how we can simplify ratios.
For the first portion of this section, students will work independently to complete the practice problems worksheets applying the new knowledge. The first page offers simple mathematical exercises that will help solidify students' understanding of the process. Page 2 offers application problems for students to apply their knowledge to solve real-world problems. This section will begin with students forming groups of 4 of their choosing to compare and discuss their solutions to the problem. Students will have ample time to discuss with their classmates their process and their thinking. While discussing their process and thinking, students will be encouraged to utilize correct mathematical language as is customary in our classroom. Each of the group will select 2 questions which they desire further information about or wish to have a class discussion about. When the groups are ready, they will pose their question to the class. Groups will be encouraged to answer questions posed by other groups first before the teacher answers the group's questions. Students will then play a 10-question Kahoot, either independently, which is our preference, or as a team, depending on the availability of classroom technology. Next, students will be given a 4-question paper quiz. The teacher can choose to record the highest score of either the Kahoot or the paper quiz, full scores, or the average of the Kahoot and the paper quiz scores in the student's individual grade book. And that concludes our mini teach of the first lesson on ratios and proportions. We hope you enjoy.